Good afternoon, YouTubers. Today we're going to continue studying a little bit this design. As you remember, this is a 5-blade propeller for an RC experiment that I'm planning to do in the future. And the main point is that this was designed out of the blue, pretty much. And we're going to analyze what will be the thrust that this blade or propeller will produce based on a particular motor that we will be using. Before I do anything on SolidWorks, remember this is part two. This design was done in part one. Part two is for analyzing to do a flow simulation. Let's study a little bit the motor that I'm planning to use for this 12-inch propeller. So for that, let me go to Excel here and show you a few things here and there. So the motor is going to be this guy here, the 2212 13T, 1000 kV motor. And the nice thing about this motor is that there's a lot of work done on it. And I picked one in particular by this guy, Experimental Technique, and he's the link for his YouTube page. He did a study on thrust for using this motor and a 10-inch blade 4.5 propeller like this one, like the one shown here. With that information, he did a setup in where he can measure the thrust of this motor by he applies some RPMs to it, and he measured the thrust. The part that is in white here, that is shown in white, is his data, and the part that is in yellow is just my adding few things here and there that I need to do flow simulation. Like for example, he did a study from 0 to about 7,000 RPMs, and this is the amount of amps that he measured, and the voltage is about 11 volts. That means that is a 3S system that he used, lithium polymer type of cells, 3S. And here's the thrust that he measured at some values. With this information, you need to calculate one of the most important things when you're working with motor is the torque, and that information is not available that quickly. So you need to kind of massage this number a little bit to get that thrust. I mean, sorry, the torque. Now, so if you have amp and volt, it's easy to calculate watts. As you can see, it get to about 150, and guess what? 150 is basically, you check the spec, is the maximum watt that this motor can handle. In fact, about 13 amp, it should not go more than 60 seconds, or you will burn the wires. So again, it's good to see that the technical data match what he did. Now, as you can see, it's about 14 amp, very close, and the amount of thrust using this type of propeller, which is a 2-blade 4.5 pitch propeller. And the next thing is you want to convert the the RPMs into rad per second. If you divide the watt by the rad per second, then you get the torque, which is the important part. That's what we are looking, and the torque is in Newton meters. Now, as you can see, the maximum torque bottoms out about 0.2. So that's the idea, because I'm not going to be using this blade. So I'm going to be using different blades or different propellers. So at the end, what is important to do comparison is never to exceed the 0.2 torque on this motor. And with that, then you can calculate anything else that you need, like for example, thrust, and that's on SolidWorks using flow simulation. So to make a story short, now that I know that 0.2 is the maximum torque that I can, drive this motor, then you can do an analysis for different scenarios like 2S, 3S, 4S. 2S is totally out of the question. If you want to have a 0.2 torque, that would exceed the amp, too much. 20.3, not good at all. A 3S, which is basically this system, yeah, that will work. You are about 13.5, which is very close to what he calculated here. And 4S, I would say it's an overkill, Definitely you can have a 4S, although I don't see that is well recommended because there's a lot of, I mean, there's a lot of energy and there's a lot of potential that you will exceed uh, the maximum of 150 very easily. So you don't want to do that. Now, saying that, the other thing that you can calculate here is these are maximum RPM done at the, basically you multiply the volts by the 1000 kV here, which meaning 1000 RPM per volt. And if you know the volt, then you know the maximum. Now, that's maximum. That's not under no load. This is under no load condition. Under a low condition, that's RPM will be reduced. And basically, I'm guessing a number somewhere here which is very much close to the numbers that he got here as a maximum RPM. And with that, you have a good idea of what. Uh, Remember, I varied this number until I got kind of a very similar maximum newton meters. In this case, torque, which is what I was looking at. Now, when you settle on the RPMs that you want to be studying, this is what you're going to do in the flow simulation software for, in this case, SolidWork. You're going to set different RPMs and you're going to see what the calculation come out from the flow simulation. What is the torque that you're going to get at different RPM? Like, for example, if I put the 2000 RPMs, and I don't get to the zero point 0.2, a value less than 0.2, means that I can put more speed, more RPMs into this motor, and there's not going to be problem. Like, for example, at 5,000, if I hit the zero point 0.2, that means that that's the maximum RPM that I can hit on this motor, together with the type of propeller that I'm using. Remember, what experimental technique did here is for this set of propeller. The only thing that I targeting is to ensure that I get the torque. So, like for example, if at 5,000 I get the zero point 0.2, that means I would never be able to run this motor at 7,000. It would not work at all. It would burn out probably you're trying to do that. So what we're gonna do now is go to SolidWork and see what will be the torque that it will come out at 3 different RPM. All right. So now that we understand where we are, let's go back to SolidWork and do some simulation here. Let's see where we are here. All right. So here's the blade. Now to prepare our study for flow simulation, in this case, SolidWorks use something called rotating bodies. So for doing rotating bodies, I need to do a few things here and there. Let me start with going to my top plane here, and let's do a sketch here. Let's get this straight. And this is what we're going to do. We're going to do a circle, a little bit larger than the, let's see, let's say that that circle would be about, I don't know, 336 maybe. That's good enough. That enclose the whole propeller. Now let's do an extrusion. And for the extrusion, let's say that it's going to be mid plane. And now let's say that it's going to be 40 and no merge. Here, take this merge out. And so the idea is that you fully enclose the propeller within that body that is going to be what we call SolidWorks call it the rotating body. That will do. So we said accept that. And now I think that we are ready to do some flow simulation. Go flow simulation here. And the first thing that we'll do is hit the wizard. And you can change the name or leave it the way it is. The unit, I will leave it the way they are. Nothing to change here. Next, SI to me is perfect because that's what I'm using. Now let's see. Anything here that I need to change? Look good. I don't see anything more to change here on this. Next. Yes, here. It's gonna be external and leave this and this like that. But it's gonna have rotation. So leave rotation, check on rotation, and it's gonna be again external, exclude, exclude. Now let's say next. It's gonna be here. It's gonna be air. Sorry for that. It's gonna be air. Everything else looks good. Next. I think that we get next here. Don't change anything here. Look good. Finish. Wait for a little bit until the wizard set everything. Now, that's a huge box for analysis. So the computational domain, let's see, can we get this smaller? You don't have to be that big. All right. There. Now. Good. Now, rotating region. This is the important part. Insert a rotating region. Now, select that rotating region. Obviously, that would be that one. Now, it's going counter, no, clockwise, and that's okay. That's the way it should go because if you remember how the blade looks like, you need to rotate that way, counter, no, clockwise. Sorry, clockwise. So that's perfect. So it's pushing the air down. That's basically what I'm saying. Now here is the rad per second that you want to put. Remember, uh, going back to my Excel table, you want to change the RPM to see that in this case, SolidWorks calculate the Newton meters or the torque that is required. Let's start by the 2000. One thing that you could certainly do here is go here and let's say here 2000, but write RPM. No problem there because what's going to happen is that it will be changed to the actual unit that the system has. No problem. So we got the 209. Let me pop this big. Let me get look good there. Let's accept that. Now one thing that you can certainly do is let's see how this looks like. There we go. You want to see where the blade looks like that I was talking about. You see, you need to rotate this in this direction to push air down. Good. So that's what the setup looks like at this point. Now, the next things that you want to do after we set that up, let's insert some goals, and that's going to be surface goal. Now the question is, let's get this delete, and let's see. The surface goal will be this face, this face, this face, this face, this face, this one, this one, this one, this one, this one. Yep, that look good enough for me. Now, how about here? In here, I want the force here because that's the only important force that I want is this one, and I also want the torque in this direction as well. So I think I got everything that I need. Good. So let's accept that. Now, how about mesh? Let's see. Mm, 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 mm. Let's go edit definition. It's kind of low, 3. I can start with that. Uh, the higher this number, the more resources we'll use from the computer. Let's say 4, and let's say OK. And now let's create mesh based on that. Run. It's running. Right here you can see it. It's popping in a different window. Let's see if I can drive it here. Preparing the model. Doing that's the mesh calculation. Total cell, loading result. So now, pretty much ready. I got the mesh. The only thing that I need to do is to run this. Let's see if I'm missing anything else. Now, the question is probably we need to run this, and that's going to take a little while. Let's see how fast it can be done. So I'm going to run, no mesh because I already, I already did it. So only solve. Now, let me look for that. It's gonna be here, and let's insert right here this one and this one. Let's say OK, and now it's doing the calculation, and let's see what's gonna happen. And that's, remember, that's a 2000 RPM, and this is the force in Newton, and this is the torque at 2000. Since this take a lot of time, about half an hour, I'm gonna cut the video here and jump to the end. There we go. About 0.04. Still some progress here on the force, but it's pretty much settled on the torque already. 0.04, not much of a, way below the 0.2 maximum, and that's good news. It's meaning that I can put more RPM and get a better thrust, because right now it's pretty crummy. I was expecting to have about 500 grams or more in terms of a thrust, and right now it's not even 100 grams, so not good. That design, is not that great. Pretty much getting done. Bingo. It's done. Yeah, loading result, and that's what I was expecting, because I want to take a look how this things looks like. So result were loaded, and now let's go here for a second, and let's go to flow trajectories. Let's insert something here, and what's that's gonna be? That's gonna be all these blades. I want to see this one, these, pretty much everything that I did originally. Surface, 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 and yep, that look good. Now, how about 50 here? It's gonna be pressure. Now, I'm interested in velocity, obviously in the y direction. Anything else? Look good. Let's accept that, and let's do some crunching here, and let's see how ugly this looks like. Excellent. Let's see. It's a lot of air concentrated right at the hub. See, very. And how about speed is in the minus direction? It's not big deal. It's a green. It's sort of like a solid green. Uh, Not much of a speed at 2000 RPM that I can tell. Mm, 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 mm. Let's go back to trajectory here and let's do play. That's how it looks like at this point. Doesn't look. Hmm. That's at 2000 RPMs. Not a big deal. It's funny how this looks like. You can see. Mm, mm. Um, let's do one thing. Stop this, and now let's go back. The goals. Where are the goals? Goal plot. Sir. Mm-hmm. Show. There we go. Here they are. So we got the torque about 0.04, 0.039. I'm gonna use that one. So let's get this number. We're gonna get those two numbers and let's copy them for 1 second and let's go back to my Excel. So let's split this here for a second. And so we know now that the torque was about that place there. And the thrust, I can put here thrust is about, let's put in grams so that we know that. 0.637, that's about, I don't know, 64 grams basically. So if I put the thrust here, that's 64 grams. So this is thrust here. 64 grams. It's not good, but you know, is what it is. So let's get this better. Looks better. Let's get this. There we go. Now let's do 5,000. 5,000 is kind of interesting. Probably gonna get close to the torque of 0.2. So let's go back again to SolidWork and fix that. So let's get out of here and let's go rotating region, edit definition. Now put here 5,000. 5,000 RPM. RPM. So accept that. And now let's run that back again. Run and see. New calculation. Now let's plot these, and these. Since this take too much time, let's jump to the end. Finally, it's getting there, but I don't like the thrust number. Uh, Thrust is about 134, meaning about 134 grams. That's very low, very low. So you need to, and definitely the RPMs, sorry, the torque is, below the 0.02 mark, meaning that definitely we need to go uh, to a higher RPM. almost about to finish. They are in the black already, and that's good sign that this is about to converge. Almost the 400 grams, not bad. Still not enough for what I saw on Excel for a simple propeller with two blades. Almost done. There we go. Finally. So let's see, waiting for, I think I load the result already. Yep. Now let's go here and let's see, show. Interesting. You can see not much pushing air down at the tip, and that's not good. Meaning that when I designed this tip, there's a lot of the I don't know. I remember. I think 35 degrees is way at the root, but at the tip is not much of it, and there's a lot of energy lost right here. So meaning that I should have provide some curvature, or that doesn't end here in 0 degrees. Here at the root it's about 35, here at the end is 0. I need more, because basically what I'm doing is circulating air and not pushing the air down, as you can see here. That's not good, and that's about 5,000. So that's a lot of waste of energy there, circulating air and not pushing it down. So you can see with this analysis what need to be fixed for your for unit testing, if you are into the design of propeller. So let's see, play. Wow, this is not good. All that circulation at the very high speed, pretty much nothing is not doing anything for you. It's not creating trust at all. So that's a problem. My next design definitely need to improve on that. Now, with that said, let's see where we are. Let's get and let me get this study out as well, and let me go back again to go plot and insert. It's gonna be this and this. I can take it to Excel if I want to, but there are only a few numbers here and they are not a big deal. So the numbers are these. The force about, and the torque close to the mark. So, but based on watts, I can go to Excel again and get some of this number going so that I complete the analysis. Let me paste it somewhere here so I can do. So basically, this is where we are. Thrust is about 382. I can set, certainly it's about 382 here. And the torque is about 0.196. Now, what I can certainly do is put here watts so that I can get this better. Like for example, if you know this, the watt here is easy to calculate, because that would be this number multiply by rad per second. Let's do this easy so that people understand what I'm doing. Let's do here rad per second. So I'm gonna change this number, and let's see, those are 2000 RPMs. That means that I'm gonna need to multiply this guy by 2 by pi and divide that by 60 and those are rad per second, and get that as well here. Now, what I need to do now is calculate the watts, and that's going to be easy. Watts in this case will be the calculated Newton meters times the rad per second. So you can see about 8 watts. If I run this at 2000, not a big deal. If I run it at 100 watts, about 5000, 100 watt, I still can go higher. The thing is how much Newton meter I will have, about 7,000 RPMs. And that's the question, because if that exceeds 150, that's not good. That will burn the motor. So let's take a look at the 7,000, and let's go back here again. Let's go back to Solidwork for a second, and let's say that we're gonna change this again, edit definition, and we're gonna get that about 7,000 RPM. Let's use this, and that's what I mean, RPM. Now we're gonna unload this, and now we're gonna run. It's gonna be a new calculation, and run. And this is the third calculation, and let's see how this looks like. I got everything there. It's preparing for calculation, and we'll see. So let's see if we get to the mark of what will be the torque and what will be the watts as shown in my Excel. I might be able to get a little bit higher than the 0.2 Newton meter, as long as I don't burn the motor, which is about 150. We'll see how fast, how can we get to the 7,000 RPM. We'll see, and what kind of a torque is required, and what would be the thrust. 5,000. Let's see, 5,000. Somewhere here, it's a little bit more than 200. Maybe this number start to look more like his number, but we'll see. Still need to hit this mark here, the 770, and we'll see that thrust, almost 800 grams of thrust. That's 2 pounds of force. Going back here to my Excel, and to my flow simulation, and let's see how the numbers start to look like. Well, for once it's jumped to the, I don't trust this number too much at the beginning, but as before, this take a lot of time, half an hour. We're gonna cut the video again, jump to the end. All right, so the system finished. As you can see here, uh, the torque is about twice of what I would like to see, and the force increased it to about 445 grams. So let's go back here and let's analyze what's happening here at actually here, and let's take a look to that show, and wow, a lot of vortex. It's a weird vortex under the at you can see a lot of still coming, you know, rotating, but now it's pushing hard, although create a lot of port. In fact, you can see some of the air coming back again. Interesting. So let's see. Let's play this. Wow. All right. So let's stop this. Um, Stop. Let's get that high, and let's go back to gold plot. Let's see that how this looks like. Show. Um, Actually, not. Let me get this out. Let me redo that again. Gold plot. Insert and show. There we go. So here we are. Uh, the force and the torque. Let's copy these two numbers and do again. Let's go here, copy, and go to Excel. Remember, I didn't use the 7150. I used the 7000. So let's change this to 7000. And the numbers that I use was that this torque is about the number that I showed there, and the amount of thrust is this number basically. So it's 446 grams. And let's see the watts. The watt will be this number times this number, and not good at all. 286. That's not good. So that pretty much let you know where we're gonna be if we try. Uh, let's do cancel here for a second. Let's clear now only. Clear content. That's it. So let me get this a better looking table here. And so this is where we are. If we operate this motor with that propeller, with the propeller that I designed on SolidWork at 2000 RPM, it will be okay, but the thrust will be pretty much nothing. No thrust, basically. Now, at 5000, start to make a little bit more sense, about 400 grams, and the watts is way below the limit of 150 watts. Looking good. Now, at 7000, oh, you are in trouble. You get a better thrust, about 500, but you exceed the maximum capacity of this motor, about 150 watt. That's 286. Not good at all, meaning it will burn. And so you definitely, the range for this motor is between 5000 and 7000. In fact, if you are interested, you can use you can recalculate what would be the proper torque here. Let's see, the proper torque in this part here. So you are looking for a torque somewhere between 0.196 and 0.391 to hit the 150. So you can do interpolation and get that quickly. What will be the proper RPM for that? Uh, well, at this point, this video is getting way too long, and basically, I'm gonna uh, do another part three, to get to the conclusion of this thrust and torque analysis. And wait for the part three. As always, thank you for watching. Bye.